Hello, good morning, my students. Yesterday we are discussing the rotary oil pump. In this class, I am discussing about the vapor diffusion pump. That means diffusion means the concentration of the molecules move from higher concentration to lower concentration. But for in this pump, we have to use for the principle of momentum transfer pumps. Okay, this is a single stage vapor pump. It has seen that ultimate pressure obtained with the mechanical pumps is of the order of 10 power minus 3. Already we are last class discussed, we get the pressure 10 power minus 3 torque. But in order to obtain the lower pressure, it is necessary to use the non-mechanical pumps, and one of this is the vapor diffusion pump. The pumping action is achieved by imparting the gas molecules into this system. Gas molecules from the system, a momentum in the direction downward to the exhaust. This is a exhaust. Backing pump is a exhaust. These are all. This is a vapor. Here we boil the oil, and this vapor goes from up to in this region. Here we get the vapor of this oil molecules, and this vapor is combined with the gas from the system. In which system we will vacuum convert ಮಾಡ್ತೀವಲ್ಲ ಆ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಬರುವಂತ ವಾಟರ್ ಇದು ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಜೊತೆ this vapor is combined and they will condenses and the gas will exhaust here, and again these vapor molecules converted into liquid, again they collected here. Again this process will repeated. That means the pumping action is achieved by imparting to the gas molecules from the system a momentum in the direction towards the exhaust by means of high speed stream of molecules. The principle and operation is illustrated as shown in the figure. The pump consists of essentially of a cylindrical body at base, which is a boiler containing suitable fluid. Provision is made for cooling the upper part of the body either by a water jets, a chimney project in the boiler, and mounted above the chimney is a umbrella shaped, this one, umbrella shaped deflector or a jet. The vapor molecules from the boiling fluid traveling up and moving the stream traveling high speed. The gas molecules which enters through the vapor stream and considerable downward momentum as a result of collision and the swept towards the exhaust. The vapor essentially collide with the cool wall, then condenses to liquid and flow back to its boiler. But the efficiency is very low for this when we use only one jet. That's why we will get the efficiency of the gas out gas or exhaust gas is very low. That's why we used multi-stage vapor pump. This is the multi-stage vapor pump. Multi-stage vapor pump. This is the speed range, and this is the for different jets there is a variation in the pressure also. In order to achieve the high pumping speed, the pump must see a large area of the system so that the gas molecules enter to the vapor stream at a high rate. Hence the jet admittance area. This is one we call as the admittance area between this jet and wall of this tube. However, a large admittance area implies the large escape area of the back diffusion of the molecules. Then we make the large number of collisions within the very short distance of the jet. Since the pumping speed is the net rate of the removal gas from the system is very high, and high back diffusion rate implies a low pumping speed, and obviously when the back diffusion rate is equals to the forward diffusion rate, the pumping speed is very low. When back diffusion is equal to the forward diffusion, pumping speed is 0. That's why we increases the forward diffusion rate is very higher than the backward diffusion. Then only we get the exhaust gas will be very high. The system pressure must be initially reduced to below a certain value, which is in most practical cases is of the order of 10 power minus 1 torque. The pressure below the jet must be kept reasonably low to reduce the probability of back diffusion. To achieve these conditions, the vapor pumps are constructed with a several jet stages. Here we use 3 stages, 1, 2 and 3 in series, one acting as a back pumping to the another. That means this is acts as a back pumping for this jet and this one is back pumping for this jet, like this. Last here we get the exhaust gas as shown in the figure. The main function of this jet is gives the large pumping speed and thus jet has a large admittance area. On the other hand, low jet have smaller admittance areas. This one, low jet has very smaller admittance area and has smaller escape areas, and vapor streams are gaseously denser. Consequently, the speed while the pressure differences in which they support become larger. It should be noticed that throughput is necessarily constant throughout the pump. That means throughput is the product of the speed and pressure of the system is a constant throughout the tube or throughout the pump. Up to this is the action of the vapor vacuum pump. Next as we go to the vacuum gauges. Thank you for watching. And also what shows the speed of the gas molecules in this region. First region 0.01 per second, this one, and this one lastly we get 100 liters per second. The speed of the pump is.